Hi everyone, thanks for joining us for the session today. I'm your host, Mala Gupta. Today I'm pleased to welcome Chandra Guntur, Director at BNY Mellon, a Java champion, leader of two Java user groups, international speaker, and a Java programmer since 1998. Hi Chandra, it's a pleasure to have you present today.
Thank you for having me here. Thank you, JetBrains.
Chandra will talk about using Maven in IntelliJ IDEA, starting from creating a Maven project, working with a POM file, to customization of Maven installations, run configurations, and much more. But before I let Chandra take the stage, let me share some quick housekeeping details. Please use the YouTube chat to post your questions. I, Alexander, and Vladislav from the JetBrains team will answer your questions as you post them. Chandra will take quick breaks while presenting to you to answer your questions, so you don't really have to wait until the end of the presentations. The session will be recorded and hosted to IntelliJ IDEA's YouTube channel. Chandra, I'll let you take the stage now.
Thank you so much. And thank you so much, Mala, for hosting, and to Vlad and Alex for moderating. I appreciate that. Thank you. So let's get started. Very quick introduction about myself. I know Mala already did this, so I don't have to spend a lot of time boring you to details. But here's my main GitHub page. I took some pain creating it, so I'd appreciate you taking a look at it. That was a joke, by the way. But yeah, so here are some of the repos that I'm active in right now. And that's me in short. So as Mala already mentioned, I'm a Java champion. I'm part of the GCP Executive Committee. I represent Bank of New York Mellon there. I've been programming with Java for a long time, and I'm a JUG leader at two Java user groups. Today, we'll be talking about how we use Maven on IntelliJ, Apache Maven on IntelliJ. So for this, I created a small project, and the link should be made available on the chat. I think Mala was kind enough to volunteer to do that. And this basically is a walkthrough of how IntelliJ interacts with Maven in multiple ways to give us some extremely good developer benefits. And we will look at those using these sample projects. There are two sample projects here. There is a Maven multi-module project, and there's a Maven single module project. First, the Maven single module project is a very simple project that is set up. The GitHub coordinates are listed here as well in case you wanted to get to it. And it is a simple project set up as a Hello World application with a Hello World test. Nothing much to it, but we are more focused on the POM XML and seeing how it operates with Maven. So that is step one. And the second project we'll take a look at is a multi-module project. Now, this is multi-module in multiple senses, in that it is a multi-Maven module, it's a multi-Java module, and it's a multi-IntelliJ module. So all three are differentiated, and there is some amount of text that helps you sort of understand and relate between Maven modules, IntelliJ modules, and Java modules themselves. So this is a JPMS enabled, a Java Platform Modular System enabled project. The project structure is like so. You got a root POM XML file, which is a reactor or an aggregator POM. We'll talk about that in a bit. We have some IDE run configurations that are already made available to you. IntelliJ does this for you. I just customize the location of where it is located. This is module one. It is datetime fetcher, and it exports a certain number of packages to be used by other modules. This is the JPMS portion of it. It is a Maven module in itself, and it is also an IntelliJ module in itself. Next comes our greeting module, which uses some of the facilities of the datetime module, and it is set up as a Java module again. It's a Maven module and an IntelliJ module by itself. And the greeting generator is where the main method exists, and this collates information from both the datetime and the greeting to create a greeting generator in certain formats. And those are the examples we'll walk through and see how Maven works on IntelliJ. So let's get started. So quick overview on how we will work through our agenda today is we have a few topics that we want to cover. And once we cover a few topics, I would like to take a break at 2 points to ask for Q&A, and Mala will help me out by looking at or pouring over the comments through the YouTube and share those with me, and I can happily answer those. So that's the format we'll go in. So please don't hesitate to ask questions. I just wanted to keep the questions sort of bucketed in certain sections. They are located with the 2 dashes that you can see, and that's where we'll take breaks for questions. So let's get started. The first thing we want to take a look at is how do we create a new Maven project? How do you use a quick start in IntelliJ? some of you may be aware of this, but all you have to do is go create a new project in IntelliJ. And once this comes up, you have options on your left navigation, one of which is a Maven. So I don't want to choose 16. 16 is too brand new, and I don't want to choose 17. So I'm going to go with 15, which is already out. Now, the way you can create a Maven project in IntelliJ is you can simply go ahead and hit next, and it creates a structural Maven project for you with nothing in it. So you get what is called a source main Java directory. As you can see on my left nav here, it gives you the directory structure, but it doesn't give you anything below, say, Java. It creates a source and leaves it there. It also creates a test directory, but leaves nothing inside. So that's a very plain vanilla Maven project. And there's not much you can do with that. So rather than do that, let's skip it and create a Maven project from what is known as a quick start archetype. Now, what you do for that is you select create from an archetype, and then you go search for Maven archetype quick start. Now, it's painful. I mean, there are so many archetypes. How do you find it?
Chandra, I'm sorry to interrupt you, but you'll have to increase the size of your font for the IntelliJ IDEA, for the IDE.
Okay, so give me a second. Let me take care of that. I have to first cancel this out, I guess. So bear with me. Font. I think we changed this. I don't know how it magically went back, but all right. Let me know if this is any better. So let me just do this again. Is this better?
Yes, this is much better. Thank you so much.
All right, great. And thank you for prompting me right away about that. So going back to where we left off is we are going to try and create something from an archetype. And then we have to go search for our quick start archetype, which is kind of hard. Now, one of the beauties of IntelliJ that a lot of people don't know about is most windows in IntelliJ support type ahead searching. So you can actually just go ahead and start typing over here, quick start. And notice I get a search, which gives me a quick start option right away. And there it is. I find my quick start Maven plugin. I move ahead, and I have to give it some name. So I'm going to give it a name of Maven demo. This is the name of my project, right? This is the directory structure name of my project. It's called Maven demo. Now, I can obviously go change the coordinates that I use for this. In this case, I would like to call it demo.cvg.jetbrains, so I don't get into any trouble with, I guess, using names that are not allowed. And this is my Maven demo. So I've created an archetype of the same name as my project folder name. And this is generally the norm. Most people generally tend to do this because you don't want to have different names. Otherwise, they show up as, the name being different from the actual directory structure, which will cause some amount of, I guess, real estate being used in the project window. So best practice, try to keep the artifact ID name same as the, directory structure name. If you don't, you'll just notice some minor inconsistencies, but it works fine otherwise too. One of the things I definitely do change when I get through this window is I like to always use semantic versioning, so 3-digit version naming. So I do include a .0 whenever I create a Maven project. So when I hit next, it again gives me a summary of everything I use. It tells me everything I've set up. I've set it up from a quick start project, and I use a bundled Maven. Now, instead of a bundled Maven, which is what IntelliJ brings to the table. I mean, as soon as you install IntelliJ, you get Maven installed, and the version 363 is what is currently available on my version of IntelliJ, which is, I believe, 2020.3. Right. So I could either use this, or I could use my own install of Maven. So if I were to search for my own install, let us say I have tools, and I have Apache Maven 363, I could choose to use this instead. So there are two flavors. You can use the bundled Maven, or you can use the Maven that is on your system. If you are working in a team project, you typically want to have a common Maven version, which is when you would use a version external to IntelliJ. If you're developing on your own, IntelliJ's bundled Maven version works very fine for you. So those are things that you should be aware of. You could add more properties here. We'll go through that as we go along. But this is some of the information that you could immediately use. So if I were to hit finish on this, a few things happen. IntelliJ creates a new project for me. And unfortunately, it is showing me a background image that should not be there. But we'll fix that later. So it created a project, right? And let's take a quick walkthrough of the project itself. So it gave me a source main And under my source main, I have a few directories, and you will notice that it created an app, and then it created an app test. Great. So I was able to create a few things. Now, ignore these because I have other plugins that I wrote that help me create some other information. So this is not going to show up on yours. It is going to show up on mine. But I just wanted to share that this is how it creates some sort of a rigorous test, which is a humor in itself, Maven project for you. Now, let me just get rid of the background image so we don't actually get confused about it being something else. So let me just change this to Maven on IntelliJ and get rid of the background. Great. So you notice that it created something, but there are a few things that you have to be aware of. The Maven Quick Start plugin is still a bit old. So it reverted back to JDK 1.7 instead of the Java 15 that I had chosen. This is a gotcha that you should be aware of. It has not yet been updated where it would actually go use the version I supplied. It originally creates a POM that is JDK 15, and then by the time it does an automated build, it somehow reverts back because of defaults elsewhere. So those are things that you should be aware of and should change. Should you actually go ahead and generate a project using the project wizard. Now, in addition, what it does is it provides for you a plugin management section. And a plugin management section in Maven is quite important. Any management section in Maven is basically a dictionary of sorts, which allows you to define a version of a certain artifact that you use, either as a plugin or a dependency. So it's a centralized dictionary that you create. And anywhere else in your project, should you choose to use this artifact, the version from this dictionary is what gets picked up. So you don't have to specify the version elsewhere if you create a management section. So plugin management and dependency management are two different dictionaries that Maven maintains and looks up the version from there in order to determine which version you will use. So there is a Maven clean plugin of a certain version, a resources, compiler, surefire, etc. We'll talk about this as we go along, but I just wanted to show you that IntelliJ creates a plugin management section up front for you, so you have zero confusion in what versions of the plugin you will use in the rest of your projects, right? And that is an important thing to have. So that is taken care of. Just be aware that the versions may be dated because of the generator still focusing on an older version of Java. So that is something to be aware of, but it's got very nifty features that you could use. So with that, I'm going to close out on generating a project. I think we're done with that section. So I'm just going to mark this as done. Okay, moving on. The next, we'll try to open a Maven project from a command prompt. And how do we do this? So first, let's go to a Finder window. Obviously, my Finder window is very small and very tiny. So I'm just going to very quickly explain to you what I'm loading, right? So I have a project somewhere. Let us say I go to conferences, and let's say I have Paneer Tikka Masala. It's one of the projects I recently spoke about, and I would like to open this project, right? The way to do it in IntelliJ is to essentially go open a project, and once you open a project, rather than just navigate to the project itself, I go to my conferences, I go to Paneer Tikka Masala. Instead of selecting the directory where my project structure is, if I were to select the POM XML instead and open that, IntelliJ prompts me with a question of, should I open this as a file or should I open this as a project? Now, if you were to open this as a project, IntelliJ parses through your POM XML and sets up your directory structures accordingly. And let us take a quick look at how it does that. So notice, it not only created my directory structure, it also went ahead and created everything that is needed to sort of set it up and ensure that it runs right away. So that is something IntelliJ offers out of the box, parsing a POM file and therefore creating a project from it without you having to do much. This is the standard way in which I usually load, I guess, any kind of source code that I checked out. If it has a POM XML, I'm immediately excited because I can immediately load it into my IntelliJ IDEA. So that is something quite useful I've found, and something I heavily recommend and use. So that I'm going to mark as done. And let's move on to the next. How do we see the structure view of a POM? A structure view is very important. I mean, if we use our Java code, for example, going to a Java code, you have a structure view, which is probably Command 7 on most Macs and similar on other devices. Is basically a representation of all the fields and methods you have in a class. Now, the same thing also applies to a POM XML, and that is something very few people are aware of, right? And here is your POM XML file broken down as a structural view. You notice that we have a model version, a group ID, artifact ID, etc. We have properties, and we have plugins, and we have dependencies listed here. All this is great, but how do I see this as a structural view? You notice that my plugins are listing Maven compiler plugin and Maven Surefire plugin, and they list up as under plugins here. Of course, even if you expand them, there is not much because we have not configured these plugins. Should we have configured these plugins with other details, they would have shown up as items under the expanded plugin slots. Similarly, we have dependencies listed, and you can notice that we have dependencies which don't have any further information associated, no exclusions, etc. So that is something that is listed, very easy for you to find out and navigate to. So I can actually navigate to whatever plugin I want just by clicking on it within the structure view. And you should take advantage of the structure view being around. It is very helpful. So of course, I know you wanted to go to properties. It's a much bigger list that doesn't have anything to drill down within the properties yet. So that is something worth noting about how Maven structure views are represented in IntelliJ. Great. Going back to the agenda, I think we can mark this as done. Next, take a look at the Maven tool window itself. So where is the Maven tool window on your IDE? Typically, the Maven tool window is on the right top. And in my case, I have shortcuts set up. I have a Command 5 shortcut set up for the Maven tool window. You may have something else, or you may not have a tool window shortcut at all, which is very easy to change. You can go to Preferences, and under Key Map, you can essentially go change the key map for, say, Maven. I set it to Command 5. Right, and you can go change this, and you can right-click, add a keyboard shortcut, and I set up my keyboard shortcut as Command 5. So that is something you can do for your own tool windows. So I don't actually clutter my screen showing all the tool windows. I hit Command 1, and I lose my project. I hit Command 7, I lose my structure, and I can get them back with a Command 1 and a Command 7, and the Command 5 gets me back a Maven tool window. So that's how I've sort of reduced the clutter on my screen itself. To make it more real estate for the actual code that I'm looking at. Here is the Maven tool window. The Maven tool window first shows me a few toolbar icons, which allow me to refresh or import Maven project. We'll talk about this later. You can generate sources. We'll go through this as well. You can download sources. You can add more Maven projects right here. We'll go through that later. And there are a few other options that you have, including settings, which we'll look at in about a few minutes from now. Now, what it does is it provides for you the Maven lifecycle that you can execute. The typical lifecycles are listed. The typical plugins used in your project are listed. Run configurations are listed. We'll talk about this in a bit. And then your dependencies are listed. So there is a lot that is already available to you within your Maven tool window. And let's go over that real quick. But before we jump into that, I just wanted to very quickly show you what a lifecycle looks like in Maven. So here is my own blog where I have a whole series on Apache Maven, how to understand Apache Maven. And one of the blogs is the Maven Lifecycles, Phases, Plugins, and Goals. This is very common hiccup for most developers, including myself, when I first started using Maven. So if you are in the boat of getting confused when you see lifecycles in IntelliJ, not sure what this is, but some senior developer in the team just comes and says, hey, just run Maven clean install. And you're like, okay, and it worked, and that's what your robotic routine becomes. You're not doing yourself and Maven a justice. So it is definitely important to understand what these are. And the chapter 4 on understanding Apache Maven goes through your life cycles. So very quickly, for you to sort of get a quick overview on what this is, there are 3 main life cycles in Maven, and you can create your own custom life cycles. Here is a clean life cycle. There is a build or a default lifecycle, and there is a site lifecycle. A clean lifecycle's main job is to clean any generated code or any generated binaries. So if you have a target within your application that was generated because of a Maven build, a clean will clean it out. So that is what is the purpose of a clean. So when you call Maven clean, you are technically calling a phase called clean within it. So this is the default phase of the clean lifecycle. So when you call clean, it actually calls clean:clean. That is something you should be aware of. Now, similarly, your build or default has several phases. And these phases are executed in order for every one of these life cycles. So when you call clean, you are guaranteed that a pre-clean will be called and you can perform some action in the pre-clean. That is something for you to be aware of. So when I call compile, for instance, on Maven, it is validating, it is initializing, it is generating sources, processing sources, etc., until it hits compile. So every phase prior to the phase you call gets called. And that is something important to know. Now, while the phases get called, they don't do anything by themselves. These phases are essentially full of goals. And goals are bound to these phases. And these goals are essentially documented or created using plugins. So when I have plugins listed in my POM XML, such as a compiler plugin or a Surefire plugin, these are linked to an actual phase. The compiler plugin links to the compile phase, which is probably the easiest way to start understanding this. So when I call compile, what Maven does is look for any plugins that are bound or associated to the compile phase. And guess what it finds within its own scope is the Maven compiler plugin. And therefore, the Maven compiler plugin is executed. And that is what is happening behind the scenes when you're running your Maven clean compile, right? And so therefore, all plugins, for example, you can declare your own clean plugin. You can create your own clean plugin associated with the clean phase and have it run instead of or in addition to the Maven clean plugin. So those are things that you should be sort of aware of on how the tool windows work and why these lifecycle phases exist. Now, going back to the lifecycle, a typical developer usually does Maven clean install or Maven clean verify. I recommend you use Maven clean verify because an install is actually a more expensive step in most cases. An install basically is taking the built artifact and putting it into your local repository. You don't need that most of the time, right? That is not a requirement, and it saves on a lot of I/O. So if you want to prevent I/O and if you want your builds to be faster, you're better off using a verify than an install. And as we already covered, running an install actually covers running validate, compile, test, package, and verify. Now, you'll ask me, why are there only a few of these listed here? Where are the other things that I saw on the diagram there? Those are less common used and they are not listed here. But you can technically call a Maven initialize, for instance. That is totally fine. You can call it generate sources, which is fine. But most of the time, we find ourselves using validate, compile, test, package, verify, install, and deploy. The rest are usually a part of something else that we are trying to run. So calling them individually does not make a lot of value add most times. But can I do it in IntelliJ? Yes, and we will take a look at that in a short while. Great. So that covers our agenda item to see the Maven toolbar, and we did a quick walkthrough of the Maven tool window. Now, in that tool window, it is possible for me to navigate to the POM itself. And I'm a big keyboard geek. I don't like to use the mouse much. So I prefer using more of the keyboard whenever I can. So if I were to Command 5, I am again back here. Now, if I wanted to actually go navigate to the source to the POM, in my IDE, in my configurations, I have set it up to be an F4 key. And that basically allows me to go ahead and navigate. Oops. Give me a second. F4 key navigates me to the actual POM XML file. And that is something quite useful. When I want to quickly navigate to a section, find out what is going on there, there is an easy shortcut for me to do that. Now, I could also go to a dependency likewise and have direct access to a dependency using my F4 key. That's how I mapped it. Your key may be different, and you may actually have other ways of doing it. So let's again go back and take a look on other things I can do here. There should be a way for me to, maybe there isn't. That's fine. But yeah, so this is how I can actually navigate to a POM from anywhere in my code. Let me assume I'm here and I just found my POM and I want to go to a certain location. All I have to do is go to whatever I want to go to and hit my F4 key or a command down or whatever you have as set up, and it takes me there. So that's something quite useful to know. So we've seen this, we've covered this, and I'm going to start there. Okay. The last thing I want to do before a Q&A break is to show you how to download sources in JavaDoc. Now, when you're running an application, it is sometimes useful to know what your dependencies source code or JavaDoc is. And there are several ways to do it. You can either right-click right here and download sources, documentation, or both. You can also download for the entire project using a download sources. And what it does for you is essentially, if this project dependency has its sources listed somewhere and JavaDoc listed somewhere in a repository, it will find them and download them for your use. And the benefit you get is you can actually navigate to those classes and find out how they are set up if it is an open source project, right? So for our example, let us go take a look at JUnit Jupyter 5 and let us see if we can download the sources for that. And sure enough, if you notice it went too quickly, my internet is very good today for some odd reason, and it already downloaded the sources for me, right? Furthermore, you have transitive dependencies within each dependency, possibly, right? For instance, in our case, JUnit Jupyter has transitive dependencies on the API, params, and engine. So you could also download sources for these. So Maven tool window allows you to sort of control everything Maven within IntelliJ. You can download sources, you can sort of run lifecycle phases, you can check your plugins, you can check your dependencies, you can download, sections of sources for some of the dependencies and plugins that you are interested in. You can do this for plugins as well, by the way. And these are the different goals that I was talking to you earlier. There's a Maven clean goal, which is the default, and there's a Maven clean help. Maven compiler has a compiled goal, and there are other, goals available to you as well. So this is the way in which you can map and start using Maven tool window. So with that, I'm going to go back to my agenda and mark this as done and take a quick break and ask Mala if there are any questions.
Hi, Chandra. Thank you so much. I'm so glad to say that Alex and Vladislav, they are answering the questions. So no questions for you. You can move forward with your presentation.
Great. Thank you. Now, so if that is the case, I'm going to move on and see how we can customize the Maven settings on the tool window. So we've looked at Maven and we've seen how Maven can help us sort of set up our project and how we run our projects through Maven. And we saw that there is a clean, there is a verify and install, and there is also a site and deploy. A site basically allows you to generate reports and create a site of sorts. So if you go to any Apache site, you notice that they have a standard look and feel with a lot of content that can change with every version, right? But the content looks very similar every time you look at it. That's because they run a Maven site on it, right? And then a deploy basically pushes out your deployment onto some external repository or some CI/CD pipeline of some sort. Great. So in order to customize Maven, there are a few things we can do. There is a settings panel, and under the settings panel, there is something called Maven settings. And this is quite a useful dialog. I'm not going to be able to go through everything. These are options that you find on Maven, and the command prompt are listed as checkboxes. Work offline, using a plugin registry, execute goals recursively are all options available to you on a Maven command line, and the equivalents are available as checkboxes on your Maven settings window. The output level is quite useful. It tells you how much of an output you want to see when you execute a Maven command. There is no global checksum policy used. Your corporate may actually have some, but we are not going to talk through that right now. Now, this is obviously if you have a multi-project, it could fail if one of the modules fails, or it could fail if everything fails, or it could fail at the first failure, etc. So there are different kinds of behaviors that are possible, and you have to just experiment with what you want to do. I rarely use the thread counts, but if you're running a massive build that has, a lot of multi-threading associated with it, both in terms of testing and in the build processes, maybe you want to change the thread count. This is rarely used, but if you do, I actually would prefer doing this from a command prompt rather than from within the IDE. Now, obviously, I have customized the Maven instance I use. So I could either use the bundled Maven or my Maven that I wanted. And in my case, I'm using my own custom Maven. Right? This is one customization you can do. If you are in a corporate world, not sitting at home doing stuff that is only going to Maven Central, then you probably also want to create a settings.xml file. This is where you set up a mirror to go to your corporate mirror of the Maven Central, which may be separated out for security reasons or for other reasons, right? So your settings.xml is a place to do it. And how can I find out more about what is this settings.xml file is in one of the blogs that I have. So in my blog on POM and effective POMs, I do mention about how you use settings.xml. What are the different kinds of settings you can have? There is a global settings, a user settings, and then there are different kinds of POMs you can use, which then create an effective POM. And the settings.xml we are talking about is the Maven user settings. And this is located in the user home under the .m2 directory. So that is something useful to know, that you can always change this by clicking override and setting it to a different value, maybe at a different directory. That is fine. And that is allowed through IntelliJ, right? The equivalent on a command prompt is for you to do a -b and point to a settings.xml location. So IntelliJ provides you for a very easy way to do that. Likewise, we talked about a local repository. When you build stuff within your IDE or within using a command prompt, if you run a Maven clean install kind of a command, any install operation will actually try to copy the artifacts into your local repository. This is the location of your local repository by default. It is under your .m2 directory, under your user home, and it is named as repository. Now, there are certain times when you just want to not use what's already available. You want a fresh start. You can always override it and name it to something else. Say, I'm going to call it JB demo. And this is my new repository, right? So I can create a repository that has not yet been touched. And IntelliJ is smart enough to go create this directory structure for me when I run my Maven commands. So that's super cool. I don't have to go create a file directory structure somewhere, come back to IntelliJ and point to it, which I can also do using this. So I can actually select a directory that is already available, or I can simply create a brand new directory, and IntelliJ actually takes care of creating the directory when my Maven commands are run. That's something useful to know. Great. So that should about cover how we customize our Maven installation for the project. You could also do it on a general basis, but this is how we do it on a per project basis. So I'm going to mark this as done. We also talked about how to customize your settings and repository. So that is something I'm going to mark as done. Now, life cycles are quite important. We already covered what the life cycles are, what the standard used life cycles are. In our case, they are clean, validate, compile, test, package, etc. And how do we run these life cycles? There are a few ways in which we can do that, right? So the first thing you can do is select. In my case, I'm going to do, let us say, select clean and verify. I control click or command click, so select both. And then I can hit the play button here, which brings up my run window, which lists everything that is being run to give me a build success. Now, the output is quite interesting in IntelliJ because it actually gives me a more UI-centric view of what is going on. Rather than me reading a command prompt, I can actually see what part failed because of a checkbox that shows as a green or a red. Now, I can further drill down. It shows me what ran and how long it took and what were the processes. So the look and feel is very similar to how JUnit functionality looks like. And it's very useful because I don't have to worry too much about, hey, what part failed? I can simply look it up, and I know if my compile failed, I would know, because the rest would fail, obviously, but at least I would know that the compilation is where my issues are, right? And that's quite nifty. Now, sometimes you don't want this. You want to see the entire content, and this is how you can see your console to look at everything going on. It can also limit to what you're looking at. So if you select, let us say, the Maven clean verify root, it gives you that it's using the library JDK15. It's doing everything and gives you the build success. However, if you're looking at just the jar, it gives you from the creation of this jar onwards until the end of the test. It does not give you the success of the entire project. It sort of helps you limit to what you're looking at. Further drilling down, my clean is exactly one step, and I was able to quickly locate it. Same with compile, etc. So IntelliJ has now provided for very easy ways for me to access what my output in Maven looks like. So they have sort of digested the output and presented it in a format that's easy for me to understand or focus on. So that's very useful to know, and that's something I wanted to share. Great. So we ran a few life cycles. So I'm going to mark this as done. We can also create what is called a custom build, right? So we just clicked on a few things in our lifecycle and hit run, and that was fine. It worked. What if I wanted to create a custom build? Like I wanted to run, say, clean and process resources, because that's all I wanted to do. I don't want to compile anything. So you can actually do another kind of build, which is basically, give me a second. Let me just create a new Maven build. You forgot the shortcut for that. I think I forgot the shortcut for that. But basically what I would do is I would go to my run configurations and create a new run configuration right off the bat. So I create a run configuration here. I can go create a plus, look for Maven, and I could do a command of clean and let us say process resources. Lo and behold, I can create a run configuration that allows me to run clean and process resources. And if I were to run this, it produces a clean and process resource output for me. So I'm able to run custom life cycles, not the standard ones listed out here. And should you have questions about what all exists, my blog should help you find out all the available phases within the life cycle that you can invoke. Great. Now you can also create a custom build. We just saw how you create a custom build. And one of the cool features of using a custom build is that you can edit the configurations. You can store this as a project file. Storing as a project file implies it gets saved as a file within your system. So let's quickly change this to, say, a JB demo. And why is this useful while I'm doing this? When you create a custom build that is useful to be shared across the team, the best way is to put it in your source control system. And here we have JB demo that I just created, and I'm saving it as a project file. It asks me for a location where I want this. The standard location is under .run. But I don't want to store it under .run because I already have a standard format I use called the /IDE. So if I were to create a /IDE directory structure, you can create whatever you want and hit apply. IntelliJ will actually create a new directory structure called IDE, and it'll store a JB run demo.run.xml. And I'm going to not add it to my project yet. But here, you can see that it created the general settings. It tells me that my options are clean and process resources, and that's the goals I'm running. So IntelliJ took care of all that, created a run configuration for me to use, and it's made available. So that's something quite nifty and useful where you can share run configurations. So I'm going to mark this is done, and this is done, and take a quick break to check with Mala if there are any questions.
Thank you so much, Chandra. Again, Alex and Vlad, we are answering all the questions, so I don't really have any questions for you now.
Yeah, no worries. Thank you. Right, great. So let's move on to the multi-module project for a bit, right? So we saw everything in a single module, and the quick walkthrough of the application that we used is there is an app, it just does a hello world, and then there is an actual test for this hello world, which is a very rigorous test of, asserting true should return true. Now, this is something that has been created as a template for you to set up your own examples, but at least there is something to start with, right? And that's what a single module looks like. Great. The next one we'll look at is a multi-module, and I'll just walk you through a bit of the code before we go further deep into it. And this is probably more important because the rest of the logic remains the same. The first thing let us take a look at is the actual Maven tool window before we go anywhere else. So you notice that I have a Maven multi project under which I have 3 projects of a datetime fetcher, a greeting, and a greeting generator. Now, ignore everything else. This is just a multi-module setup. And the moment you create a multi-module structure, you notice that Maven also creates multiple modules in its own tool window, including one marked as root. Now, let us take a quick look at the POM, the root POM. And you will notice that my root POM has 3 modules in it. It has a datetime fetcher, a greeting, and a greeting generator module. And those are the 3 modules you will see listed in my Maven tool window. Now, some of the nifty features that I wanted you to be aware of, which are not, not expected, but super cool to have, is I can actually control click on the modules and actually go to their POM definitions. This is super useful. I mean, this is something that is not documented anywhere, but it is so nice to be able to just navigate within modules by clicking on their module names. and IntelliJ takes me to the actual POM XML file. I love this feature. So this is something I use quite often when I'm dealing with multi-modules, and I find it to be quite useful to be able to navigate just by clicking on items. Now, here is a good example of a plugin management where I have defined plugins of a certain version in my plugin management. And in my other projects, say my datetime fetcher, I don't have to define anything because it's a standard plugin. But if I were to put in a plugin, I don't have to specify the version number for it anymore. It's defined in the plugin management. So that is something that is nice with, I guess, Maven in general. This has nothing to do with IntelliJ, but that you can create a dictionary of sort up front using a plugin management or a dependency management and control the versions that you use. Great. Now, how does this whole module setup look like? A quick walkthrough on IntelliJ itself. This is known as an aggregator or reactor POM. So this POM is not defining itself as anything more than a parent to certain children POMs. So this is a parent POM of some sort, but I'll not call it a parent POM. It's an aggregator POM because invoking commands on this POM, the root POM, will actually invoke the same commands in this order on the 3 POMs listed. So datetime fetchers POM will execute the commands I execute on the Maven multi. Then greetings POM will execute the same commands, and then greeting generator will execute the same commands. So for instance, if I were to run a Maven clean on Maven multi, datetime fetchers clean will be run, then greetings clean will be run, and then greetings generators clean will be run. So that is the order in which things proceed, and it's pretty standard. And what I'm doing is a decoupled hierarchy in Maven. That is something useful in that a parent can declare children, but the children may associate no relationship with the parent. That is possible. In that case, it's called a reactor POM or an aggregator POM. In such situations, the parent simply drives or aggregates the results from each of the child POMs. The reverse relationship is called parentage, where a child POM may optionally declare a parent. In our case, we do. And by declaring a parent, it inherits all the details from the parent. So properties declared in the parent, dependencies declared in the parent are inherited by the child POM as soon as it declares a parent. So that is something useful to know. There is a bidirectional hierarchy, but it is not mutual all the time. You have to specifically and explicitly declare hierarchies. So in other words, I could have not declared modules here, just created a POM and have my datetime fetcher have it as a parent, in which case it was a child to parent relationship, but no parent to child relationship. That is something very interesting in Maven, and it is very powerful a feature. It requires bidirectionality to be explicitly specified rather than implicitly implied. And that is something useful to know. Great. And how do I know more about this? So once again, shameless posting to my own blog. I basically have a blog on this aspect as well, on how your POM hierarchies are controlled. So please feel free to go navigate to the POM hierarchies and it'll tell you all about this information. Great. Coming back to our code, this was our datetime fetcher. And how is this set up? We talked about it being multi-modules. These are Maven modules. Let's quickly go back to our README and understand modules. So I'm not going to spend way too much time here, but I just wanted to share. Maven modules are a way of defining your project structure, right? So they are structural modules. You can group items into different structures. A POM declares a downwards hierarchy of modules as an aggregation, and the child POM can optionally declare a parentage as an upward hierarchy, right? And these are mostly well suited for version control and for structural control. So that is quite important to know about Maven modules. IntelliJ modules are quite similar to Maven modules. They perform almost similar actions. They are focused on the structure, JDK versions being used, customizable sources and resources per module, etc. So Maven and IntelliJ sort of work hand in hand when it comes to their concepts of modules. While they are still a bit different from one another, they are quite similar in nature to what they are doing. Java modules, on the other hand, are nothing related to these two. Java modules focus a lot on strong encapsulation, preventing certain information from being leaked out to other modules, or I guess, selectively sharing what can be leaked out, etc., is the purpose of a Java module. Java modules do not control the versions of Java, nor the subproject artifacts. So they are slightly different and skewed from IntelliJ and Maven modules. So while IntelliJ and Maven modules are still different from one another, their area of focus is very similar, whereas Java modules has a completely different area of focus. Now, how do you set up Java modules? Obviously, when you start with the Java 9 and above, you'll notice that you first have to create a module info.java file at the root base package that you're trying to use. And let's take a quick look at the base package here. I have a module that defines my module name, and it exports, I guess, 3 packages. And there is a reason we export the 3rd package. It's because of JUnit tests, because we use one static method there. So this is somewhat of a gotcha case. You usually don't have to do this opening of a certain base package. And opens versus exports is basically how you use. And exports is basically where you can only make the code available, so you can compile alongside. And opens is also available at runtime. So that's something that you should be aware of as a difference. And we use opens because of our JUnit test in the on line number 8. So that's an example of a module info. We can go into a lot more detail about this on, I guess, should time permit. But at least for now, you have an understanding of how a Java module is set up. You saw how Maven modules are set up. Now let's take a look at IntelliJ modules. So if I were to go to my project module structure, and how did I get here? I can right-click on my project, and in here, I should be able to find an open module settings, and I could get there. And notice it's called a module, and these are your modules. They're very similar to how Maven modules are. You have the same modules listed there. They're very similar to Java modules because those are the same names listed everywhere. Now, the differentiator is that the IntelliJ modules basically give you the ability to specify your source folders, your test folders, your resources, etc. So if I wanted to mark, say, something else as my test folder, maybe under target, I have a generated sources. I would like to add this as a test folder, source folder. So I could mark it as a sources. And now you notice that target generated shows up as a generated sources source. Now, this is something I don't want to do for this project, but you can definitely do that. So that is where an IntelliJ module distinguishes itself from a Maven module. It is more towards the structure of the code that you're executing within the IDE. You're better off controlling most of your modularity, if for lack of a better word, in Maven rather than within IntelliJ, and use IntelliJ sparingly to make it a convenient IDE to use. This way, other team members who have different setups don't have to worry about recreating the same infrastructure. Now, depends on the team culture. Some teams actually sort of push in to source control their project settings under .idea. Certain others don't. But if you use Maven, you're sort of limiting yourself to not having to sort of share the .idea folder structures. May be useful in some cases, may not be useful in some cases. You are the best distinguishers and you can make the best decision, but both options are possible. So that's something I wanted to share. Great. So this is the multi-module. We took a look at how module info.java looks like. Let's go quickly to take a look at our Maven structures. You have the datetime fetcher. It has its own life cycle. You have the greeting, which has its own life cycle, and so does greeting generator. I don't want to expand everything, but here is your root. This is the root POM. Now, if I were to execute the clean install on my root POM, it would imply I'm running a clean install on all of these. If I were to run a clean verify instead, because I prefer a verify over a clean install, you will notice that it executes my Maven multi, then my datetime fetcher, then greeting, and then greeting generator. And I can see the outputs of individuals, right? So they give me all the outputs that I need to look at, and they are available as consolidated Maven command line output across everything, or individual outputs should I wish to actually delve into each one of them independently. So that covers Maven multi-modules. Let's go back to the agenda to see how we're doing. And Mala, how are we doing on the time? Are we doing okay?
Let me just check, Chandra. So we have 11 minutes left, and I think you can take up all of that time because no questions for you.
Okay, great. Thank you. All right. So the last two things that I wanted to talk about are dependencies, diagrams, and terminal use, right? Run anything is probably the sledgehammer of tools, which is probably my best and most favorite Maven command, IntelliJ command that I use. So I'll talk about that too. So very quickly, right? If you go to your POM, sometimes you just don't want to see stuff in text. Text may actually not solve your problem so easily. Maybe you're a visual person. What do? So you can actually go to your POM structure view and look for diagrams. And you can actually say, show me the dependencies as a picture. So when I do this, instead of showing me text, it starts showing me a pictorial representation of how my connectivity is. So it shows me that I have a Maven single, and I use Log4j API, which is Log4j2, and I use JUnit Jupyter. And within JUnit Jupyter has certain transitive dependencies of, say, Jupyter API, Jupyter Engine, and Jupyter Params, which then have further transitive dependencies. So if I were to use some sort of exclusions, this is the place where I will see it visually. It's quite useful to do that. You can also drill down over here. There are some options you can choose. You can show conflicts, you can show paths, you can show neighbors of selected node, etc. Quite useful. And this is probably very useful in sharing across with, let's say, the architects that look at your source code. You can save this as a UML diagram. So some very useful features in the dependencies as a diagram is possible through IntelliJ. And I love this feature. I think this was one of the first features that sold me on just sticking with IntelliJ to use Maven. It is amazingly useful. It's very nifty, and I heavily recommend that you use it. Now, if you have a very large graph, it also helps you because you start seeing overwhelmingly number of dependencies, and you would want to cut it down. When you see it in a POM XML that you have 5 dependencies, you may not understand that you're probably pulling in 25,000 dependencies because they have many transitives, right? But with this picture, everything becomes much more clearer, right? This is closer to you generating an effective POM. Now, that said, Maven also allows you to generate an effective POM from your POM XML. That is something quite useful. So you can also go to the POM XML, and under Maven, you can show the effective POM. This is the textual version of the same content. And the effective POM is nothing but a mash down of all your settings and all your parent POMs into this current POM and create what is known as one single effective POM that gets run for whatever product artifact that I want. It's very useful because it has all the information that you need. It has all the dependencies that I picked up. It has all the repositories that I'm going to, plugin repositories I'm going to. I guess where my source and everything that is default on Maven that you don't customize is something you can get to see using the effective POM. Right? Tells you all the plugins you're using, tells you how your plugins are configured for you by default. So you learn a lot by going through the effective POM, and IntelliJ does an amazing job of rendering that output for you. Now, certain things will show up in red. Ignore them for now because those are more of my personal settings and how I set up my IntelliJ. Yours may look different. But that's something very useful to know. And I don't know if you're already aware or if you've already used this feature. IntelliJ now supports what's called a reader mode. And for POMs, it does not make a big difference. But if you're in a Java class, the output looks amazingly crisp. So that is something I heavily recommend that you sort of check out. We can do a quick example on that if we had the time. It's something I find very interesting. So let's just go to Logger. Let's take a look at the Logger API. And you notice how my output is so well organized. It is readable text. The Java doc has been converted into actual text that is readable. So that's something I find very useful. And although it's not related to Maven, I just wanted to share how awesome this feature is. Great. So that was that. And I think let's go back to the agenda to see what I did not cover yet. So we covered this. So I'm going to mark this as done. Terminal usage. You can also use a terminal. Forgot my shortcut for the terminal, so bear with me. So I'm going to hit clear. And since I'm at my project, I can just do an LA and notice that I have a POM XML right here, which means I can run my Maven commands right from here within my IDE. Now, there are two things I can do. Notice the green pop-up that came up. You may not be able to read the text, but it is super cool. Although I'm using a terminal, it is telling me that IntelliJ can take over and parse the output and show it to me in the standard run window. So let's do that. So let's first run it as a normal Maven command instead of something I want IntelliJ to do. And you notice that actually it produced all the output on my command prompt, which is fine and dandy. We expected it to work, and it did. Now let us do the opposite. Let us instead allow IntelliJ to take over. So here I'm going to run a Maven clean verify, and I'm going to just say command enter instead of enter, and IntelliJ tool window picked it up. That's kind of nice. There is a terminal integration now. So my IDE is understanding the terminal and picking up commands from there. I love this feature. This is so cool because I'm more of a keyboard person and I like to just type things in and I see my output show up in my standard dialog windows. Something that you should leverage and use. In my IDE, the shortcut is command enter. If you were to go to your own terminal and type in a Maven command, IntelliJ will prompt you on what to use for your specific operating system. That is something super cool, and I heavily recommend using it. So I'm going to mark this as done. And moving on to my probably the favorite feature in IntelliJ IDEA, I heavily use this feature, and I think everybody should too. So this is my feature. In my IDE, it goes Command-Shift-A, and I do run anything. And this is the sledgehammer of every single tool that you want. So if I wanted to open another project, so if I wanted to open the Maven multi-module, guess what I do? I just type open Maven multi-module, and lo and behold, I'm in that. So keyboard geeks, keyboard fanatics like me, absolutely enjoy having the run anything. It is probably my favorite command in IntelliJ IDEA. Now, why am I bringing it up here is I can actually show you something super cool, how IntelliJ has integrated with Maven. And you will probably appreciate it when you look at it. So when you type Maven, IntelliJ gives you all possible options that you can run with Maven. So you don't have to remember options. You don't have to learn them. You get them all directly from the run anything dialog. And it is super cool. So I simply type something here, verify, and lo and behold, IntelliJ runs it for me. And I absolutely love this feature. So those are the things that I wanted to share. We are about 3 minutes remaining. So I wanted to wrap up here and see if there are any further questions.
Thank you so much, Chandra. It was, I would say, a rock star session. And attendees, they are thoroughly enjoying it. They are in for a treat with the live demonstrations. And you are just amazing. And everyone, yeah. And everyone from the attendees, thank you for attending, for asking the questions. And if you like the session, which I can see from the comments that you did, don't forget to like the video. So Chandra, as I mentioned, that Alex and Lord, they answered most of the questions. So this is one question. I'm not sure whether you would like to answer. So there's a question on, should I be choosing Maven over Gradle as my build tool?
That's a great question, and that is something I'm happy to answer. I like Gradle, I like Maven, I like both. They have their own individual use cases. So if I'm in a corporate world where I want fungibility of my people moving from one project to another without them having to spend a lot of time deciphering the build system, but focus on the actual code, I would prefer Maven. The biggest, I guess, hiccup to using Gradle in a corporate sense is that Gradle is extremely customizable. Not that Maven isn't. So Gradle allows you to create a script. It allows you to program your build. And sometimes it is not ideal for an IDE to pick up a Gradle, I guess, heavily customized script and convert it into the project format that you want. Versus Maven is driven by convention. So you don't get to do much in terms of customization on the XML itself. Should you want to tweak, you create new plugins, right? So there is an entire life cycle for that, an SDLC process for that. So it depends. Now, on the contrary, on the con side, when I'm working on my private projects and I develop IntelliJ plugins and I develop Android apps, Gradle is the way to go. I only use Gradle for that because number one, IntelliJ plugins can probably don't work or at all or work very badly with Maven. So it's Gradle I prefer there. Same goes with Android. Anytime I'm creating an Android project, the first thing I have to do is set up a Gradle, right? That is pretty much normal for me. But at workplaces, I think the norm should be to use something that is more convention driven. So that's how I distinguish between the both. but don't think either is bad. Both are equally good at what they do. It is just that they have different goals.
Thank you so much. That was, I would say, an excellent answer. And there is also, I would say, our team on the chat. Rodrigo, Julian, Sovik, Nacho, Neha, all are here to kind of support this session. Thank you so much, every one of you. Um, and as I said, don't miss to like the video because I thoroughly enjoyed the session. And once again, thanks, Chandra, for presenting. This was an amazing session. And thanks, everyone, for asking the questions. And also, please stay tuned for our next live stream on March 17th, which would be on profiling your applications in IntelliJ IDEA. Thanks again, and we'll see you soon. Thanks, Chandra, once again. Bye.
Bye bye.